All right, good morning, everyone. So first, I would like to apologize for not being able to meet you last Wednesday. I had some internet difficulty. Some internet difficulties. Simula no ano nung Tuesday ng gabi siguro or Wednesday ng madaling araw, nawala yung internet namin. Actually, I think 7 municipalities here in Laguna, yung service provider namin ay down talaga. So, no internet for more than 24 hours. Ang hirap pala ng walang internet, ano? So, and then I tried using mobile data na hindi naman nag-work. Pero kasi last semester or even before, nagtuturo talaga ako mobile data kasi before, mahina rin yung internet provider ko. Hindi na ako nagba-mobile data pagka nagkaklase. Pero yun nga, nagka-problema sila last Tuesday. So luckily, it was now resolved. So again, I apologize. So what I'll do, I'll just make up for it and do a lecture on the labs on Monday. I will propose to the lab instructors that I handle the lab class na lang on Monday. So everyone will be invited to join dun sa D2L lab on Monday. And as that is the case, we won't have any laboratory exercise on Monday. Okay. So actually, that is already planned. Hindi ko talaga kayo bibigyan ng lab exercise for Monday because I know you are doing your problem set which will be due on kailan ko nilagay yung problem set? May 19 nga ba? I hope that's right. So yeah, on the 19th, right before midnight, 11:59 p.m. That's the deadline for the problem set. And as before, there are 3 parts to it. Part 1 is an essay part. I suggest you be as concise as possible. Actually, to tell you frankly, natu-turn off ako kapag multiple paragraphs na yung sagot dun sa essay type. Usually, I just require students to or I usually require students to just answer essay questions in at most 3 or 5 sentences. Pero parang hindi ko siya nilagay na instructions sa inyo. Pero humahaba masyado yung mga nobela nyo, no? Wherein in fact, when I am checking, pagka nandun ako sa, pag nag-check na ako post-deadline, so ang dami na nakapila. Pag essay question, I am actually just skimming through your everything that you wrote, especially if you wrote something very long. What I do, I'm just looking for keywords, yung mga keywords na hinahanap ko. Pag hindi ko siya nakita, kahit gaano pa kahaba yung sinulat nyo, hindi nyo mapa-perfect. Ano? So meron akong mga key ideas na hinahanap. Usually, this is just a phrase or a full sentence na pag nalagay nyo yun, automatic, perfect 2 points na. Pero kung mahaba yung sagot nyo, nobela yan, ang daming formulas, nag-prove pa kayo, but you fail to mention the actual idea that I'm looking for, you won't get for perfect credit. So just focus on delivering your message concisely at huwag nyo nalagyan ng mga palabok. Especially yung mga proofs, hindi ko siya kailangan kasi malamang nasa module yan or in one point in my life nabasa ko na yung proof. So kaya gusto ko galing talaga sa inyo on your own words yung sagot nyo sa essay part. Ano? Yung part 2 is computational aspects. So here, I gave you a crash course on a Galerkin method and tawag ay method of moments, pagsasolve ng integral equations. So try to read it, lalo na yung preamble. Tapos siguro if you have questions, I can address them on Monday. Kaya rin siguro partly kaya gusto kong ako yung mag-discuss sa lahat ng labs on Monday ay para masagot ko yung mga questions nyo if you do have some regarding the problem set, okay? So because I really want the problem sets to be more than just testing you. Okay, kasi hindi na uso yung nag-exam lang tayo para malaman ko kung natuto kayo or hindi. Alright? So dapat ano lang yon, part lang yon ng assessment process. But I am trying to devise my assessment tools para may matutunan kayong bago. Especially if it's in a problem set na pag-iisipan nyo for a whole week. So meron talagang time para matuto kayo ng isa pang bagay. So rather than just asking you to mechanically apply a method that we have programmed before, so kaya gusto ko may makuha kayong bago mula dun sa mga problem sets. And then the third item is objective part, which basically may isang true or false yata doon, tapos may tatlong right-in. So you have to put in your numerical answers. Be mindful of the format being required for your answer. Okay? So because when you hit submit, ipapakita niyo na yung solution, ipapakita niyo na yung correct answer, so hindi niyo na mababawi. So make sure binasa niyo yung question, chinek niyo kung ano yung format, kung ilang decimal digits ba yung hiningi kong input. Kasi ang sinabi ko kay Canvas, eto lang yung sagot mong tatanggapin. Walang margin of error, ano. So kung ano yung eksakto kong hinahanap na number, kung 4 na decimal points or 4 na decimal digits, then yun lang yung ibibigay nyo dapat sa akin. Okay? So I'll be happy to answer questions on the problem set on Monday. So make sure you read through the problem set over the weekend. So para we can have a meaningful discussion on Monday. What else? Yeah, and we are in the last few days of the semester. So as such, I want you to start planning about your project. So the project would just be similar to what you did in Math 174. Yun nga lang, yung techniques kasi dati natin, interpolation, numerical differentiation, numerical integration. Ngayon, papalitan natin ng techniques on root finding, solving systems of linear equations, and solving ordinary differential equations. So, ganun pa rin yung mechanics, at most four members per group. Kung ano nga yung cutoff natin? Kung solo or dalawa kayo sa group, parang write up lang yung kailangan nyo. Pero kung kayo ay 3 or more, i-double check yung guidelines natin sa 174. Ano? Tapos pag marami kayo, kailangan niyo ng video presentation na recorded lang din naman. Okay? So I'll release a detailed guidelines over the weekend. So para masimulan nyo na. Siguro mag-open din ako ng isang Google form para malaman kung sino yung mga gustong mag-work in a group pero walang kakilala or wala pa nakakukuhang ka-group. So para ma-group ko sila. But aside from that, I'll give you the freedom to choose who to work with. Okay? So kayo na yung bahala ron. So more on that probably over the weekend or early next week. Okay, so now we are on the last unit of the course. So, ibig sabihin dito, pupunta tayo dun sa pangatlong klase ng mga equations na isosolve natin. Ngayon, ang isosolve naman natin ay mga ordinary differential equations. So, before we begin, can I see a show of hands? Ilan sa inyo yung marunong mag-ODE? When I say marunong, siguro nakapag-take na ng Math 151. Sige nga. Okay. 7. Okay, so I think at least 10 of you guys are already familiar with ordinary differential equations. May mga ilang hindi nagtaas ng kamay, so I don't know if they are familiar or not. But just to make the discussion complete, sisimulan ko yung unit by a quick introduction to what ordinary differential equations are. Tapos saka tayo pumunta sa numerical solutions to ODEs. Problema kasi, pag hindi sa atin klaro yung ibig sabihin ng ODE at kung ano yung hinahanap nating solution ng ODE, parang useless na turuan ko kayo kung paano mag-numerically solve ng ODEs. Kasi parang bibigyan ko lang kayo ng black box as mag-i-input kayo without understanding what actually is being done inside that black box. So yun yung ayokong mangyari. So that's why I will probably spend at least half of today's lecture introducing you to ODEs again. And probably it would be a good review, especially for those who already took Math 151. You know? Required pa ba sa applied math ang 151? Hindi ko tanda na yung curriculum. Kasi nung time ko, yeah, may mga klase ako na applied math. Okay, good. So required pa rin sa applied math. Yan nga lang, it's a shame, at least for me, na yung mga math majors hindi na required mag 174, you know. But anyway, so the objectives for this module, you know, is to first teach you how to do Euler's method and for you to employ it to solve an ordinary differential equation, and then perform a convergence analysis of Euler's method. Probably we'll do it on Monday. And third, use Euler's method to solve scientific problems. Okay. Saka, eto pala, yung lagi nating huling objective, yun yung dahilan kung bakit may computational part tayo na medyo konting high-tech dun sa ating problem sets para masabi na pinangatawanan ko yung objectives ng mga modules natin. Okay, so let's dive into the topic itself. So an ordinary differential equation is an equation involving the derivative. So it's just that simple. Meron kang equation, pag may derivative ka nakita ron, isa yung ordinary differential equation. Now, that derivative pala should be should be the derivative of a function. Kasi para sa function mo, ang tawag natin doon ay partial differential equation. 38. Pero essentially, yun nga, mga ODEs, ito yung mga equations na nag-involve ng derivative ng isang function of a single variable. And they are very important because they are used as the models for anything that changes through time, or with respect to any other variable. Kasi nga yung derivative, siya yung model natin para sa instantaneous change. And sabi nga nung isang adage na the only constant thing in the world is change. So if that is the case, then most of the things in this world are changing with respect to one variable or another, or at least one variable or more. So talagang napaka-useful ng ODEs. Ang problema sa ODEs at saka sa mga PDEs, ang hirap nilang isolve analytically or kasi meron nga actually mga ibang mga ODEs na hindi solvable or may mga ODEs or PDEs na hindi pa natin alam kung solvable sila or hindi. I think there is a Millennium Prize problem about partial differential equation that when you solve it, you're gonna get $1 million. You know? Pero mathematicians already tried for decades to solve them. Pero hanggang ngayon, ilang pang Millennium Prize problems yung outstanding. So baka ano man, teacher niyo ako, no? Baka naman pwedeng bumala to. But anyway, going back here, so ang isang ordinary differential equation o ang isang simpleng ODE can take the form of equation 10.1. So it's a partial differential equation involving the function x of the variable t. Okay? Medyo nag-adjust ako dito ng konti. So si x yung function, so siya yung dependent variable. Ang independent variable natin ay si t. So I use t because usually model natin using derivatives, using ODEs ay mga quantities that vary through time. So time usually yung independent variable, tas kinukuha natin yung rate of change with respect to time. Okay? So ODE ito talaga kasi meron kang derivative. You have x prime or the derivative of x with respect to time on the left-hand side. While on the right-hand side, you have an expression f, which involves the dependent and the independent variables. So si f, isa yung expression na nag-i-involve ng function x at saka ng variable t. Okay, so this equation 10.1 tells us the instantaneous rate of change of x with respect to, say, the time variable is expressible as a function of the dependent variable and the independent variable t. Okay, and f can take a lot of forms. It could be linear, it could be non-linear, etc. So dito tayo magkakatalo-talo sa complexity ng function f. And this is an explicit method kasi yung derivative kaya nating isulat in terms of a function na wala nang derivative dun sa right-hand side. Okay, pwede kasi na meron pang derivative na involved dito. But we will not consider those complicated cases. And for those cases na kailangan yung mas malaking analysis, I think they are more properly discussed in an actual course in numerical ODEs or numerical PDEs kasi napaka-rich nung theory behind them at hindi kakasya sa 1/3 ng Math 175 yung mga topics na iyon. Okay? So if you have an ODE of the form 10.1, so ang goal mo, hanapin sino-sino yung mga functions x na nakakasatisfy ng equation. So this is quite different from what we discussed in the previous two topics. Pag meron kang root finding problem, naghahanap ka lang ng isang real number o isang complex number na nakakasatisfy ng equation. if you're solving a system of linear equations, you're looking for a vector of real numbers that will satisfy the given system of equation. Kakaiba yung ODE. Sa ODE kasi ang hinahanap natin ay mga functions. Okay? So ano yung mga functions X na makakapagbigay sa atin ng identity 10.1? So ibig sabihin, pag meron akong function X, dapat pag kinuha ko yung derivative niya, equal yan dapat sa expression F as a function of X and T. So yun yung unang pinagkaiba nito. Ang solution dito ay yung function X. So kaya, which makes it a little difficult kasi hindi lang isang number yung hinahanap natin. Hinahanap natin ay isang function. Okay? Now, to illustrate, I have here example 10.1. Ito nga yung mini crash course natin sa ODEs. Let's consider equation 10.2. So in this equation, we have dx dt equals t over x. So here you can think of t over x as our function f of x and t. Tapos meron tayong derivative dito sa kaliwa. Okay. So ang sinasabi ng equation 10.1, hanapin natin lahat ng mga functions x na ang derivative with respect to time can be written as t all over the function itself. Okay? So maraming methods on how to solve ordinary differential equations. I guess the simplest one, which I guess even if without you taking 151 ay nakita nyo na sa Math 36, ano, ay yung separable differential equations. A differential equation is separable if we can literally separate the variables from each other, or I mean put them into separate sides of the equation. So here you can treat, we have two variables, the independent variable t and the dependent variable x. To separate them, kailangan lamang lahat ng may x lagay natin sa kaliwa, lahat ng may t lagay natin dun sa kanan, counting the differentials. Okay? So instead of looking at dx over dt as a single quantity, as the derivative, we look at it as the ratio of the differentials of x and the differential of x and the differential of t. So ibig sabihin si dx ay isang quantity, si dt ay isang quantity. So what we can do is to multiply both sides by what? We multiply both sides by x dt. Okay? So if we multiply both sides by x dt, we'll get this line. Okay? So parang tipo na cross multiply ka lang, treating them as fraction. And it's a nice thing because then the variables are separated from each other. Tapos kaya gusto natin silang separate sa isa't isa. Lahat ng may x, kasama yung differential of x nasa kaliwa, tapos lahat ng t, kasama yung differential of t nasa kanan, ay para pwede akong mag-integrate both sides. Okay? Kasi nga gusto kong mawala yung mga differentials. Gusto kong mawala yung dx at saka yung dt para mahanap ko yung x as a function of the independent variable t. Okay? And one way to get rid of derivatives ay gamitin yung kanyang inverse operator. Kabaligtaran ng differentiation ay integration. So yun yung idea dito sa separable differential equations. Okay? Now, I integrate both sides. So kayang-kaya na yan, Math 36 stuff. So we'll get x squared over 2. Sana hindi ako nagkamali, mapapahiya ako eh. No? Equals t squared over 2 plus a constant of integration c1. Of course, if you integrate this, you should have gotten an arbitrary constant. So dapat meron to ng plus, halimbawa plus d. Kasi ito merong plus e. Pero i-transpose ko na yung d dun sa kabila. So magkakaroon ako ng e minus d. D and e are both arbitrary constants. So their sum or their difference will also be an arbitrary constant. Tawagin ko na lang siya na c1. Kaya dito na lang siya nag-appear. Okay? And then I can further manipulate this by multiplying both sides by 2 para kasi ang goal ko ma-isolate si x sa isang side ng equation. So I'll get this. Nagkaroon nga lang ng transformation because c1 will be multiplied by 2. But c1 is an arbitrary constant, so twice it will also be an arbitrary constant. So c na lang yung ilalagay ko. And then finally, I take the square root of both sides. So I'll get the function x in terms of the variable t. So x can take the form of plus or minus the square root of t squared plus c. And I claim that this is the family of solutions to my ordinary differential equation. Okay? So medyo refresh na ba sa pinakamadaling klase ng ODE? I saw some heart reacts kanina. Hindi ko alam kung para saan yun kasi baka delayed yung yung feed sa laptop ko. But yeah, I hope that that makes sense. Okay. Now, kung meron kang duda, all right? Uso yan ngayon, yung mga nagdududa or nangangamba, no? So, to get rid of those anxiety, pwede nyo namang i-check kung tama yung solution nyo dun sa ODE na given. And that is looking at the derivative of x and see if it is equal to t over x. Okay? So, I differentiate this. So, for that, I'm going to use the power rule and then the chain rule, right? So, this is t squared plus c raised to the power 1/2. So, plus or minus, kinopya ko lang doon. Tapos 1/2 derivative, then chain rule. And then when I do the simplification, it turns out it is really just t over c. Okay? Remember, pag nag-differentiate ako, ito yung magiging denominator because of this guy. Pero ito, exactly siya si x. So indeed, dx over dt equals c over x. So ito ay yung family natin ng mga solutions dun sa ating ODE. Okay? So the thing here is that we have the form for all possible x's that can satisfy this equation. So usually we call this the indefinite solution or the general solution because this is really the class of solutions for the ODEs. So kahit anong function na solution dun sa ODE ay kayang masulat in this manner. So magkakatalo-talo lang pala sila dun sa arbitrary real number c. Okay? But usually, especially for real-life applications, we want to look for a particular solution that corresponds to the scenario or to the application we are modeling. So, halimbawa, meron ka pang ibang information about the ODE or about the system that you are modeling. Halimbawa, alam mo lang yung feasible region o alam mo lang yung domain. Ano lang yung mga possible values ng independent variable. For instance, you want this to be true only for a time frame from 0 to 5, say, seconds or 0 to 5 years. Tapos alam mo yung initial value, the value at the right endpoint of the restricted domain. Pwede mo siyang isama dun sa modeling. Now, once you have an ODE plus an initial value, ang tawag na dun sa problem ay isa na siyang initial value problem or IVP. Kasi ang given sa atin yung value dun sa left endpoint. Okay? Now, the system 10.3 to 10.4 can be solved by first looking at the general solution and then solving for the arbitrary constant c. Actually ngayon, di na siya arbitrary constant c. Pipili na tayo ng constant c that can give us or that can satisfy the initial condition 10.4. So among the classes of solutions that we have gotten earlier, okay, yung plus or minus square root of t squared plus c, pipili tayo ng isa sa kanila by picking the right c so that x of 0 will be equal to 1. Yun yung habol natin, mas-satisfy yung initial condition. And how do you do that? Well, that's easy. Once you have the general solution, just plug in the initial value for the time domain. Ano? So here, our initial value for t, or ito yung given dun sa equation 10.4, given yung value ni x at time t equals 0. So plug in mo lang yung t equals 0. We know that by the condition, it should be equal to 1. Pero alam natin yung general solution, ito yung itsura. So plug in t equals 0 into it. And that's fine. When you plug in 0, you get a plus or minus root c. Remember, this is an or. Okay? So para ito ay maging totoo, dapat si c ay equal kay 1. Tapos kailangan i-disregard na natin yung negative sign. Okay? Kasi kung ititira nyo pa yung negative sign, then you cannot find a number such that negative square root of that number will be equal to 1. So among those family of solutions, we are interested in the solution x of t equals t squared plus 1. Okay? Pwede nyo rin i-check. Oh, okay, sige, yan ay nandun sa family of solutions. But will this satisfy the initial condition? Yes, because you just replace x by 0, we get x of 0 equals 1 as desired. Okay, so that's the most basic type of differential equations, yung separable. pero hindi lahat separable. Ano? So maraming klase ng mga ordinary differential equations. Nakita nyo na yan sa 151. You spent almost a semester para tingnan yung iba't ibang cases. Siguro isa pa, para medyo ma-refresh talaga tayo. Tingnan natin yung example 10.2. Sa example 10.2, given tayo ng initial value problem, dx over dt equals 1 plus x over t. And the initial value is 1, okay, because our time interval goes from 1 to 6, and the initial value is 1. That means x of 1 is equal to 1. Now, so dito sa problem na to, ito na yung ating f. Ito yung f of xt. Tapos naghahanap tayo ng function x na ang derivative niya with respect to t ay equals sa 1 plus sarili niya all over t. And also, na ang value niya sa 1 ay 1. So ito ay isang linear differential equation because the function f is linear in x. Is linear in x bar dapat or t? This is linear in x. Pag yung right-hand side ay linear sa x, ang tawag natin doon ay linear differential equation. Tapos pag linear yung ODE, pwede natin siyang isolve by integrating factor. Okay? So math 151 is waving. Ano? So kung tandaan niyo pa yung mga methods sa pag-solve. Pag meron kang linear differential equation, pwede kang mag-introduce ng integrating factor. And the integrating factor is actually e to the power at, okay? Where a is the integral of the multiplier to the linear term in x. So kasi ito ay linear in x, pwede ko itong isulat na 1 or constant plus a function of t times x. Alright? Kaya siya sinabing linear in x. Kasi isa lamang siyang linear kung lahat ng t ay i-treat ko as a constant. So it's linear in x. If it is linear in x, then ang integrating factor niya ay e to the at, where a is the integral of negative a of t. Right? So dito sa ating problem, yung a of t natin ay 1 over t kasi siya yung multiplier dun sa linear x. Ano? So 1 over t yung ating in-negate, tapos i-integrate para makuha yung integrating factor. Okay? So the integral of this guy is ln of 1 over t. Supposedly, we could have chosen any constant c because sa integrating factor, bahala ka. Pero pinakamadali, i-set na lang natin yung c to be equal to 0. So I will choose my integrating factor to be e to the ln of 1 over t. Kasi dapat e to the at yon. Alright? So, and this guy will be what? This guy will be just 1 over t. So yan yung integrating factor na i-introduce ko. Right? So going back to our ODE over here, what I just did here is to put x over t on the left-hand side. Tapos ngayon, mag-multiply ako ng integrating factor to both sides. So the integrating factor is 1 over t. So I multiply every term by 1 over t. We got that. And the reason why I specifically chose that integrating factor kasi pwede kong makuha or pwede kong gamitin yung product rule in reverse. Note that this guy, all right, ito yung derivative ng x times 1 over t. When sort of you take when you apply the product rule, right? Because when you use the product rule, you'll copy the first times derivative ni second. And in derivative ni second with respect to t, that's negative 1 over t squared. So the first term would be negative x over t squared, and that's this guy. Tapos yung pangalawang term naman, copy the second factor, differentiate the first. This is 1 over t times derivative of x with respect to t, and that's this guy. So talagang product rule ito, yung nangyari rito. Okay? So yun yung kagandahan ng pag-i-introduce ng specific integrating factor na pinili ko. And then the right-hand side is as is, wala tayong magiging problema dyan. Tapos etong quantity na to, instead of looking at it as a differentiation process, I can look at it as a quotient of two differentials. Yung differential ng x times 1 over t over the differential of t. Tapos ngayon, ang gagawin ko, kukunin ko yung dt, i-multiply ko siya dun sa kanan or to both sides. Okay? So essentially, multiplying both sides by the differential of the independent variable will give us this guy. Okay? Tapos ano na yung mangyayari? Well, I will integrate both sides. But the nice thing about the integration this time, isa lamang tong lone differential. So if I will let y to be equal to x times 1 over t, so this will just be integral of dy. At tanong integral ng dy. Ang integral ng dy ay y plus an arbitrary constant. So this guy should be y, pero yung y ko ay x times 1 over t. So I got that here. Right? Tapos, integrate ko yung dt over t. That will just be ln of t. Supposedly, there should have been an absolute value here. Yan yung formula na natutunan natin sa 36. But remember, our time variable only ranged from 1 to 6. So, ibig sabihin, okay lang, naitira ko dyan yung t without the absolute value bars. And then the arbitrary constant here, c, represents the aggregate of the constants coming from the integration on the left and on the right. And then writing x explicitly in terms of t will give us the following solution. So this is our general solution for the ODE given in the example. All right? Kaya lang meron pa tayong initial condition na kailangan is-satisfy that, but that's fine. Look at what the initial condition is. It tells us that x of 1 is equal to 1. And then I can look at x of 1 two ways. I can look at it using the condition given on the problem, and I can use it, I can view it as an evaluation of the general solution when t is equal to 1. So gagawin ko lang, login ko lang si 1 dito, ito yung makukuha ko. Then simplify, solve for the specific value of c we want for our problem. ln of 1 will just be 0, so essentially this will just be c. So that means we need to choose c to be equal to 1. So the particular solution we're interested in is this guy. X of t equals t ln t plus 1 times t. Okay? All right, so okay na ba yun? The jump start na ba yung understanding nyo ulit about ODEs? So kita nyo talaga, hindi lang isang number yung solution dun sa problem natin. Kailangan family of functions or at least one specific function that satisfies not only the differential equation, but also the initial condition given. Okay. Now, the two examples that we have seen are relatively simple. But in particular, the second example, kahit napaka-simple niya, ang komplikado ng solution because you need to think of an integrating factor and so on. And imagine what will happen if we have a much more complicated partial differential equation. Now, the two ordinary differential equations. The two ODEs that we have seen are first order. First order sila kasi first order lang ng derivative yung nakita nating involved. Meron mga ODEs na meron second order, meron third order, fourth order. Parang yung SP na gagawin ni Denmark, second order yung gagawin niya. Tapos hindi lamang second order, system siya ng differential equation. So imagine the complication that will bring. So kailangan natin ng iba't ibang methods. Ano pa ba yung mga ibang methods? Meron pang method of undetermined coefficients, merong method of merong Fourier or Laplace transforms. Ano pa ba? Basta, marami pang methods. Magagalit sa akin si Ma'am Jean. Hindi ko tanda yung mga tinuro niyang methods. But essentially, yeah, yun yung problema. Napaka-komplikado ng mga ODEs. And some of the ODEs are even not solvable by hand or are proven to not be solvable by hand. So, kaya yun yung motivation kung bakit gusto nating mag-solve ng ODEs. And actually, mag-solve ng ODEs numerically. Okay? And actually, that's the trend. Since computers are invented, mathematicians actually started looking for ways on how to implement solutions to known equations or known types of equations using machines. Kasi may teknolohiya na nga naman, why not take full advantage of it? Okay? So yun yung motivation. So ang unang pinakasimpleng method na i-discuss natin ay yung Euler's method. So we will be looking at a numerical way of solving the IVP given in equation 10.7 and 10.8. So, ang una nyo gagawin, kung implement nyo yung Euler's method, kailangan nyo muna siyang isulat in this manner. Dapat x prime equals an expression involving x and t. Pero yung mamaya makikita natin na malamang ito ang papalitan ng mas generic pang form. Okay? Pero ito yung initial form na gusto natin. And then we will be given the initial value or the value at the left endpoint of the interval of interest. Tapos bibigay natin ano yung constant value. Okay? So the exact solution to this system or to this IVP is a continuous function, right? So function yung hinahanap natin. Pero kilala na natin yung computers. Alam na natin yung limitations niya. Hindi niya kayang mag-output basta-basta ng isang continuous function. So kailangan tulungan natin ng konti yung machine para mas efficient yung solution. And I mean, bibigyan natin siya ng input, tapos bibigay siya ng isang output na hindi ganun kahirap niyang makukuha. So ang gagawin natin dito sa mga numerical methods ay kukuha tayo ng isang discrete approximation para dun sa continuous function. Instead of searching for, say, a continuous function whose graph is, say, like this, na makakasatisfy ng system 10.7 to 8, ang hanapin na lang natin instead o ang ipapahanap natin sa computers ay isang discrete set of function values. Titingnan lang natin yung mga function values o yung mga points na naglalay dun sa curve. 1, 2, 3, 4, 5, 6, 7. So halimbawa ito, kukunin ko lang yung value ng solution o i-estimate ko yung value ng solution sa 8 points. Tapos yung collection ng 8 data points na yon, yun yung i-consider ko as my approximation to the solution to the ordinary differential equation. So the search for a continuous function ay i-reduce natin to a search for a discrete set of data. Okay? So ang sagot dito ngayon, isang vector ng mga function values at different time values. Okay? Medyo mas high-tech dito yung gagawin niya sa problem set. Kasi sa problem set, ang problem ay umanap ng continuous function f, tapos ang output niya talaga ay continuous function f. Dito ang ating output ay isa lamang vector consisting of function values or estimate to the function values at specific time time values. Okay. Now, the idea here is i-mesh natin o i-discretize natin yung domain given, yung interval AB, hatiin natin siya into, say, capital N points or capital N plus 1 points. So start tayo dun sa left endpoint, siya yung tawagin nating time 0. Then pipili ka ng time 1, time 2, hanggang time N, which is equal to the right-hand side. So there's a total of N plus 1 data points to be had. Okay? For brevity of discussion, adapt ko itong following notations. Yung x of ti, the function value of x at the ith time step, ay denote ko na lang by x sub I. Tapos yung function value ng derivative at the ith time step, i-denote ko lang by x sub I prime. Tapos ang goal natin ay maka-generate ng isang set ng mga values w sub i's such that bawat isang w sub I ay i-approximate niya si x sub I. And this will go from from I equals 0 hanggang I equals capital N. Okay? So one way to get such a set of approximates w sub I, yung ODE sa 10.1 or sa 10.7, ito yon, yung ODE na to, papalitan natin ng isang difference equation. So hindi siya magiging differential equation, magiging difference equation siya. How can we do that? Well, I will just replace the derivative by an approximation. Okay? Yung pinakamadaling approximation sa derivative, kung maalala niya sa numerical differentiation natin, ay x of t sub I plus 1 minus x of t sub I all over t sub I plus 1 minus t sub I. Okay? So, kasi ito yung change in the x value, which is a good estimate for the differential dx. Tapos ito namang ilalim siya yung differential of the independent variable. So ito yung ipapalit natin. Ito yung tinatawag natin na difference equation. Now, it is a good approximation to the derivative when t sub I plus 1 is very, very close to t sub I. because actually this will become equal to the derivative when we let t sub I plus 1 to be close to t sub I. Or baliktad, yung t sub I papalapitin ko sa t sub 1. Kasi pag kinuha natin yung limit nito, as t sub I approaches t sub I plus 1, then we will get dx over dt, the exact derivative. Kasi yun yung definition ng derivative, di ba? Yung limit and difference quotient. Habang yung denominator ay papalapit ng papalapit kay 0. Okay? So, yeah. So, yun yung gagawin ko. Papalitan ko siya. Tapos yung function f, pwedeng maging mas komplikado na siya. Okay? So, it will be turned into an expression phi, which will not just depend on the time value and the specific approximation for the value at the ith time step, alright? Magdedepende na rin siya dun sa function f na given dun sa problem. Posibleng may involved na w sub I plus 1 dun sa right-hand side. Tapos, pwede siyang mag-involve din ng h sub I, where h sub I is the increment on the I plus 1 step. So, pag sinolve natin yung t sub I plus 1 minus t sub I, tawagin lang natin yun na h sub I. That is ang tawag natin ito. Siya yung time step when you are on the I plus 1 stage in the approximation. Okay? So ito yung idea. And then when phi does not depend on w sub I plus 1, ang tawag natin doon sa method na yun ay isang explicit method. It is explicit because w sub I plus 1 then can be written as something that depends only on f, t sub I, w sub I, and h sub I. Pero kung wala kang maggagawa, pero si phi talaga involves si w sub I plus 1, you cannot simplify it further, then that is called an implicit method. Tapos para ma-solve yung isang implicit method, so kailangan mong isolve ito times this guy. Probably, kaya hindi mo ma-isolate si w sub I plus 1 from phi. Malamang ito ay isang transcendental equation. So, kailangan mo yung root finding techniques na natutunan natin mula sa Unit 1. Okay? Para lang ma-solve yung w sub I plus 1. Okay? Now, another thing is that this is called a one-step method. It is a one-step method kasi para ma-solve si w sub I plus 1, kailangan nating alam ay yung value ni w sub I. Yung isang previous value lamang ng w ang kailangan kong malaman para ma-solve yung panibagong value ni w sub I. Okay? So that is in essence, kailangan mo yung value at the previous time step or your estimate from the previous time step to have the value at the new time step. Kaya siya one-step method. Now, there are some methods that are multiple steps na kailangan mo halimbawa para ma-solve si W3, kailangan mong alam na si W1 at saka si W2. So that's a two-step method. Okay? And then what we will discuss here today is an example of a time marching algorithm. Time marching siya kasi magsisimula tayo sa W sub 0. Pero si W sub 0, alam natin, isa-set na natin yan to be equal to the initial value. After all, di ba gusto natin si W0 ay equal kay x sub 0. But x sub 0 is x of t sub 0, which is already given in the problem. So yun na yung pagsisimula natin. So ang W sub 0 natin ay alpha. So sa initial condition, walang error na nagaganap. Kasi eksakto nating sineset yung W sub 0 to be equal to the initial value given. Okay? Tapos, para after nating makuha si W sub 0, or ma-initialize si W sub 0, mako-compute ko si W sub 1. Kung one step lang yung method natin i-consider. Alright? So, ito yung first time step. Tapos, sa second time, tapos para ma-compute si W2, kailangan ko yung value ni W1, and so on. And then remember, each of the W sub i's represent or estimates the value of x at a particular time step. So kaya siya tinatawag na time marching o time stepping algorithm kasi from one time value, you will proceed to the next time value. So successive yung pagko-compute natin ng mga estimates sa bawat time value. Kaya siya marching algorithm ang tawag. Okay? Ano pa bang gusto kong sabihin? Okay. So I think we're ready to talk about Euler's method. Siguro mangungutang ako sa inyo ng 5 more minutes or 10 more minutes para matapos to. So, hang out lang tayo guys until 1. Okay? So, ang unang method nating i-discuss ay si Euler's method. Now, Euler's method is an example of an explicit one-step time marching method. Okay? So, and then it is actually, the derivation is easy because we'll just take advantage of one familiar concept from calculus, yung Taylor series expansion. So what I'll do is, I have a function x, which I will assume to have continuous first and second derivatives. So wala na tong 2. Dapat continuous lang yung first at saka yung second derivatives. So yan lang yung hihingin ng Euler's method. Tapos kung totoo yan, pwede kong i-expand si x in its Taylor series expansion around t equals t sabay. Okay? So equation 10.9 gives us the Taylor series expansion. Sir, bakit Taylor series yan? Finite lang yung number of terms. Well, it is finite, pero kasi yung second term ay meron kang x double prime of c, where c is between t and t sabay. Remember, I think sa isa nating discussion last time, pinrove ko using mean value theorem na yung expansion, yung isang series expansion, ay kaya nating i-truncate into any number of terms you want, but we will just, the last term will represent the error term, okay? For some unknown c, which is between t and t sabay. Okay? So you can think of this guy kagad as the error term, because we cannot compute this guy because in the first place, we don't know what c is. And actually, there's another problem because we're solving for the function x, so we don't have any info about x double prime, ano? So yun yung magiging problema natin dyan. But anyway, so that being laid down, pwede ko nga yung i-evaluate etong expression 10.9 at t equals t sub I plus 1. Kasi remember, gusto kong magkaroon ng formula para kay x sub I plus 1. And I'm hoping that that formula that I find involves only x sub I. Yan yung tanging pangarap natin. Ano? So para makuha si x sub I plus 1, kailangan ko lang i-plug in kay x yung t sub I plus 1. And per the notations we adopted earlier, this is equal to x sub I plus 1. And voila, yan na yung left-hand side ng example, anong equation 10.10. Okay? Tapos, x sub I is copied over. Tapos, let's call this, and then I'll plug in t sub I plus 1 here. So we'll have t sub I plus 1 minus t sub I. Oh, that's just h sub I. Tapos rito, actually, my typo. Sorry about that. This should have been x of t sub. Dapat x of t siya. All right? Kasi dito pa lang ako magpa-plug in ng t sub I plus 1. And, sorry. X prime pala to dapat. Yan. Pasensya na. Alas 2 ko yata sinulat tong module kahapon. Ano? So, x prime of t. Tapos, di ba, remember, pero saan equals si x prime of t? Sir, hindi ba yan magkakaproblema kasi hindi nga natin alam si x. So, paano natin mahanap si x prime? But if you go back to our expression, okay, we have this. X prime is equal to f of xt. So, basta nakakita ko ng x prime, pwede ko yung palitan ng f of xt. Which is fine because in the problem that you'll be given, alam natin kung anong itsura ng right-hand side. Okay? Because the derivative is equal to the expression f. So the x prime here in our derivation can be replaced by f of xt. And that's what I got here. I plugged in t sub I. Pero remember, si x ay function ni t. So ipa-plugging ko si t sub I plus 1 dyan. Sorry, ano ang pinlogin ko? T sub I plus 1. Okay. Nalito ako, sorry. Tama pala yung kanina. Sorry, lutang moments. So ito ay x sub I, right? Remember sa Taylor series expansion nga pala. So you have the value of x at the value of x at the evaluation point, at the center of expansion rather. Then you have the step size times the value of the function itself on the center of expansion plus 1/2 h squared times the derivative times evaluated at the time step. So tama ito na x sub I nga pala. All right? Sorry, x sub I prime. Yon. Ayan. Final answer na yan. X sub I prime siya dapat. Okay? So pero si x sub I prime, kung matatandaan nyo, ay equal yan sa x prime at t sub I. Okay? Pero alam natin si x prime, according to the given problem, ay equal kay f of x sub I, comma t sub I. Alright? Kasi si x prime of t ay equals sa fx, comma t. Si x ay function ni t. So this guy should be x of t sub I. Pero notation natin sa x of t sub I ay x sub I, comma the time value t sub I. Right? That's why this guy x sub I prime, dahil wala tayong info about x sub I prime, isusulat ko na lang siya in terms of f. Tapos this guy will be 1/2. This is h squared pag nag-plug in ako ng t sub I plus 1 dyan. And then this is a constant. It's x double prime evaluated at c. Okay? Now, if you look at the first two terms of the right-hand side of 10.10, this is something that we can compute. All right? And this is actually, nakita natin na siya ay explicit method. Ito yung tinatawag natin na phi, which depends on f, x sub I, t sub I, and h sub I. Okay? Wala ditong x sub I plus 1, so meron tayong explicit method. Tapos x sub I lamang yung kailangan natin para makompute yung x sub I plus 1. So this is a one-step marching algorithm. Okay? So now dahil hindi natin alam yung exactong function values, but we want to create a sequence, or not a sequence, but a collection of data points. So papalitan ko lang lahat ng x sub I dito by our estimates w sub i's. So first, w sub 0 will be given by the initial condition, and then lahat ng x dito mapapalitan lamang ng w. Essentially, we'll have w sub I plus 1 equals w sub I times h sub I times f of w sub I, comma t sub I. And this recursion formula is what we will use in order to generate the values at the different time steps. Ezekiel, tanong ni Ezekiel, ano yung mga w sub i's? Yung mga w sub I, sila yung approximates natin doon sa mga x sub i's. Kasi remember, hindi natin alam si x. So, hindi natin alam yung mga x of t sub I. Pero ang idea rito ay, hati-hatiin ko yung interval AB into t sub 0, t sub 1, t sub 2, t sub 3, and so on hanggang t sub n. Tapos ang goal natin ay makahanap ng makahanap ng mga w's na makaka-estimate ng mga function values. So, pagka si I ay 1, oo nga no, kulang pala yung nandito ko. Yeah. Thank you, Ezekiel. So tama, ito dapat ay from 0. Okay? Yeah. So yan, makukuha na natin yung w sub 1. Thank you, Ezekiel. So, yeah, yun yung gagamitin nating recursion formula. So meron pa tayong 5 minutes, so siguro kaya kong no, thank you, Ezekiel. That's my oversight. Ngayon ay siguro kaya pa nating tumingin ng isang example. Okay? So tingnan natin. Let's use Euler's method to approximate the solution dun sa separable differential equation na nakita natin kanina. Okay? So here we were told to use the uniform step size 0.5. So yung interval natin ay 0 to 5. So i-discretize ko yan simula kay 0. Step size ay uniform na half. So this would be 0.5, 1, 1.5, 2, 2.5 hanggang makarating tayo ng 5. So gusto natin makahanap ng estimate sa function value ni x doon sa 11 data points na yon. Okay? And then we were told to do an error analysis. So it's important nga pala that you read the examples in the modules kasi usually yung ilang discussions dun siya na-introduce dun sa ating mga examples, okay? And you do the error analysis by computing the relative error at every t subice kasi yung bawat t subice ang nire-represent niya ay mga function values sa iba't ibang data point, sa iba't ibang time values. So they are independent of each other. Kaya kailangan nating makita ano yung relative error at every time step. So yun yung magiging analytic description natin para dun sa error. Now, to have a visualization of how good the estimates that we got, pwede nating i-plot yung ating mga estimated points doon sa ibabaw ng exact solution because anyway, we already know what the exact solution is. Pero itong second condition, usually hindi natin yan nagagawa in practice kasi hindi natin alam yung exact solution talaga. Kasi what's the point of doing numerics if you can't solve the problem or actually if you have solved the problem already symbolically, you know? So gagawin lang natin yon for the purpose of illustrating how accurate the method is. Okay? Tapos later na lang natin i-develop ano yung error bound kasi nga hindi natin alam kung ano yung actual solution. Now, in this particular problem, so this is our f. Our f of xt is equal to t over x. Tapos ang h natin ay 0.5. So we plug that into the Euler's method. So ang initial condition natin w0 ay equal kay 1. Tapos tayo pa uli, dapat ito ay 0 to 10 para kompleto yung iteration. So remember we have w sub I plus h sub I pero sa lahat ng I, ang h lagi, ang step size ay 0.5. Tapos ito yung f of w sub I, comma, t sub I. Alright? Okay. Tapos ito lang. So, alam natin yung, meron tayong value ni w1. Tapos alam natin yung mga values ng lahat ng time elements. Okay? So, ibig sabihin, pag alam ko na si w0, pwede kong computein si w sub 1. Alright? It's just gonna be 1 plus 1/2 yung 0 time value, which is what? Which is 0 divided by 1. Tama ba? T sub 0 ay 0. Okay, good. So tama pala. Dito ako nakatingin kung bakit yung x sabay ko ay 1.11 pero magiging 1 lang siya. Kasi ang t sabay ay 0, no? So ito ay 0. Ang t sub 0 ay 0. Tapos so magsi-0 to. So ang w1 ay equal lang kay w0. Yan pala yan. Okay. So kinabahan ako din ng slide. Pero ganoon. Tapos pag nakuha mo si w1, so you get w1 plus 0.5 times t1 over w1. So that's going to be 1 plus half times 1 all over w sub 1 is 1. So you'll get 1.25. Okay. So doing this process for all the time values na nakuha nating discretization points, ito yung table of values na makukuha natin. So ibig sabihin sa time t equals 0, eksakto yung ating approximation. W sub I is exactly x sub I, and that is by design. On the first time step, maganda yung actually hindi ganun kaganda yung approximation kasi ang nakuha nating estimate para sa x of 0.5 ay 1, pero ang true value ay 1.1180. So it entailed a 10.56% error. Okay? Pero sa time 5, sa t sub 10, dun sa right endpoint, ang w sub I na makocompute natin ay 5.04. Ang x sub I na gusto kong i-approximate ay 5.09. So medyo hindi pa rin pala ganun kagandahan because we'll get what? We'll get, hindi, maganda na pala to. This is about 1.24%. Okay? So hindi natin pwedeng masabi ng error dito sa buong approximation process ay 1.23% kasi yon ay error lamang dun sa pang-10 or pang-11 time step. Okay? So that's why I suggest you look at two things. The average of the relative errors, okay? So ang average relative error dito ay 4.62%. So that will give you roughly an idea ano yung error or ano yung average error sa lahat ng time steps. Or better yet, you can compute for the L2 relative error. Okay? So the L2 relative error is given by yung vector ng mga W's minus vector ng mga X's ng actual solution. Kunin mo yung L2 norm ng vector difference nila divided by the norm of the exact vector solution. Tapos, makukuha natin ay 3.43%. Okay? So si curly W at saka si curly X, sila lamang yung mga vectors na ang laman ay yung mga W's and X's respectively. Okay? Hirap kasing magsulat ng ng malaking W at malaking X na hindi siya mako-confuse with little W's and little X's. So kaya curly W's and X na yung ginamit ko. Now, I'll talk about global discretization error na lang siguro on Monday, but I want to end by looking at the graph or this picture. Okay? So ito yung gusto kong makitang visual comparison ng mga solutions kasi kung 100 points yung gagamitin nating time steps, hindi magandang tingnan yung 100 na rows sa isang Excel file isang MATLAB screenshot. So it would be nice to have a visual representation of the solution and vis-a-vis the exact solution if we know the exact solution. So pwede nating gumawa ng isang scatter plot, okay, showing the data points. So ang data points natin ay yung blue dots here or yung blue circles dito. Yan yung mga W sub i's na na-compute ko. So yan yung nagpapakita sa akin ano yung estimate ko sa t-value na yon para dun sa x of t. Alright? Tapos, ano ba si MATLAB, instead of a scatter plot, pwede siya mag-interpolate ng mga values para sa pagitan ng dalawang data points. So pag pinagawa natin kay MATLAB yung interpolation or whatever internal algorithm it uses, so pwede niya ma-connect the dots using a curve na siya na yung magko-compute, siya na yung magde-determine. Kay MATLAB, pwede niyo itong gawin na plot ng vector t at saka ng vector w, i-output niya itong red line na makikita mo or yung red curve. Tapos, gusto ko itong i-compare dun sa actual solution para makita na gaano kaganda yung estimates natin. Well, if I plot the actual solution, we'll get the, what color is that? Yellow ba to o orange? Orange yata to initially. Pero hindi ko alam kung orange pa rin sa screens nyo. Tapos makikita nyo na, medyo off siya ng kaunti. Alright? Doon sa actual solution. And actually, this is understandable or this is to be expected because we knew that the L2 relative error is about 3%. Tama ba yun na 3%? Or nagkamali ang kopya? Yeah, tama. 3.43%. And that 3.43% cost a significant or at least not a significant, but at least a noticeable difference between the actual solution and the exact solution. So one thing that we will ask next is, paano ko pala mapapaganda or mapapalapit yung dalawang curves? Ano yung mga pwede nating adjustments na gawin? And apparently, we'll discuss this more. Pwede ko palang palakihin or padamihin yung number of points na i-consider. Okay? So dito, instead ng step size ay ang step size ay 0.5,